Dear friends, welcome to my channel. My name is Johannes. This is part 3, solve the examples on diversion error, which covers concrete glacis weir or slope weir, floor thickness, mutual interference, and corrective pressures at key points will be seen on this session. So let's see examples. So example 3.5, Khosla's theory for concrete glacis weir. Let us see, for the section of concrete glacis weir or slope weir, you can see the downstream part which is slopey with 1 to 3, and the upstream is also 1 to 5. So this is concrete glacis weir. So determine the uplift pressure at key points using Khosla's theory. Check also whether there is just the weir is safe against uplift and piping. We will check against uplift and piping and take G 2.24 and safe exit gradient given 1/7. So you can see the dimension and also the elevation and also the given floor thickness and water level, which is at 205 meter, and upstream concrete floor beer level 202, but downstream you have 200, and also you have 3 sheet piles. The first one is the bottom level of the first sheet pile is 197, and the second one the same 197, but the downstream pile is 194. So let's see the example. So first you have to determine the dimension. So the total floor dimension is not given. So you can see you have here 8 meter between upstream and intermediate pile, and also you have horizontal floor dimension 10 meter, and the other not given. So if you have slope 1 to 5 and 1 to 3, you can see just the horizontal distance or the horizontal distance of the sloping floor. So you can see for downstream floor, we know that slope is vertical over horizontal. So you can see the vertical increment from 212.4 minus 200 is subtract horizontal, and the slope is given 1 to 3. So if you just make crisscross this one 1 to 3, 12 meter, which is this one. You can see this is 12 meter dimension. So once you get 12 meter and you have this one height of this, then the total floor dimension will be the summation of 10 plus 12 plus 2 plus 10 plus 8, then it will give you 42 meter. So this is the total floor dimension. So if floor dimension is not given, please take advantage of upstream and downstream slope so that you can determine the exit slope vertical to horizontal. So this is total 42. So using Khosla's theory, now let's see upstream pile. This is upstream pile. Since you have 202 meters, then you have bottom elevation of the sheet pile. So you can determine now. You can determine just the depth of sheet pile. So the depth of sheet pile is 202 minus 197, so it will be 5 meter, and bottom dimension already 42 given. So you can just determine now. You can determine the other parameters alpha, which is B over D. So you have B total 42 and D 5, then 8.4. So 8.4 is given. So just you can have alpha, and 1 over alpha will be this one to use for Khosla's chart. Then once you have determined this one, the next step will be from Khosla's curve of plate peak 11, 1 over alpha versus alpha. You can determine these values from Khosla's curve. I will show you that one after a minute. Then you can just have these values 5D and 5E. So you have at the depths this one and E here you have. So once you calculate this one, then let's go to lambda, which is just using empirical equation. You can determine lambda 1 plus square root of 1 plus alpha square over 2. So you get this value. Then once you have this, then so from empirical equation, phi d 100 over pi cos inverse of lambda minus 1 over lambda is equal to, then you can multiply, then finally you have 21.08%. So this is just the pressure at the depth D of the sheet pipe. So be careful on this one. It should be in radian measure, otherwise you will turn the wrong way. So this is just in radian measure. I will show you the calculator. So phi D1 will be 100 minus this one. 100 minus phi D will be 78.91%. And phi E1 will be 100% already. This is the entrance. Just the seeping of water is entering through this one. So at 100% it will enter. Then finally it will go like this. Then it will just go like this under the base of the floor of the weir. So as much as possible, you have to determine phi C1, which is this one. So phi C1 will be 100 minus phi E, so 69.58%. This is the result. So once you determine phi C1, phi D1, then you can have phi E, just 100 over pi cos inverse of lambda minus 2 over lambda. Then you have 30.419. 30.419. So I think this is important. So let me show you. The calculator and also other parameters you can determine. So this is just C1 means this one, just back of this E1 and D1 here. So pipe at upstream end will be like this. So this is the width of the floor. Then you have to determine this E1, C1 and D1. And E1 already at 100% it is just entering. The seeping of water has 100% potential here. So that's why. So let me show you the calculator now. Your calculator should be converted into radian, this bracket side. So you can see this here, the bracket sign. Inside this bracket should be in radian measure. So your calculator should be converted into radian. Just you click mode here. You click this mode, then just replay. So this replay. If you replay, then next you can have this one, rad. So please select rad. You have to select rad. This is just rad once you get mode, or just double click mode, then you get rad. So you should select number 2 in your calculator. Then your calculator is adjusted in radian measure. Then you can just have this formula, empirical equation, cos inverse of this in bracket. So this one already in radian measure, then you get this result. The same is true for phi D. So I hope this is important. Now let me show you the Khosla's chart again. So for the first upstream pipe, we have calculated 1 over alpha, which is this value here. This value already computed previously. Then clear. So for 0.119, which is 1 over alpha, then you just read. You just read here. You go to this one. So you have curve of phi D. This is phi D curve. Clear? Phi D curve, and this is phi E curve. So according to Khosla's chart, you just go down. But you should be careful on division of this. From 0 up to 0.2, you have 10. So it will be 0.01. So you go 119 around here. So you read this part, you go at this point. Once you touch this point, you go horizontal, then you have to calculate 30.4. This is 30.4 for this one, 1 over alpha. Then phi D1 will be 78.91. Clear? Then again for the second phi C1, again you just calculate 30.4, and then you have phi C1. So once you have phi D1, phi E, you have 21. This one. Then finally you should compute. So once you have this result, you can just calculate again. You go just here you have 2 points. This is for phi d, this curve you read 21, and this point for phi e. So for phi e you go horizontal, you just have this one. So you just have these results, two results, phi c1 and phi d1. So once you compute this one, then again for the second part for downstream pi, you have 1 over alpha 0.1429, then phi d will be 22 and phi e will be this one. So this is 0.1429. You just go like this. Once you intersect this point, then you go horizontal to this one, then it will be 22.9, and you touch this phi e curve, then you go horizontal, then you will have 33.17. So 33.17 and 22.9 for downstream pile we will take as it is. But for upstream, you have to subtract from 100% because the seeping water is entering 100% head, then you should just deduct this value. So that's why we are just deducting. So this is for upstream sheet pile. You can use for upstream and downstream pile. So for upstream pile and for downstream pile, you have to use this one. Clear? You should use these results. Clear? So I hope this is for upstream and downstream piles. Then finally, we can have just corrected pressure later on. So this is one. Then let's go to the second down intermediate pile now. For intermediate pile, how do you compute for intermediate pile? For intermediate pile, let us see. You have to have alpha 1, which is b1 over d, 8 over 5, 1.6. So you have b1, which is the intermediate pile from upstream pile, 8 meter. And if you subtract from 42 meter, you have 34 meters. So b1, b2, d, then total b. You have 42, and the floor you have here 202 meter for intermediate pile. So you are going to calculate alpha 1, then alpha 2, b2 over d, which is 34 over 5 equal to 6.8. Then lambda, you should have this empirical equation, 1 plus alpha 1 square plus 1 plus alpha 2 square under root. Then you get this result. So this is the result. Then you have again just lambda 1, which is 1 plus alpha 1 square minus 1 plus alpha 2 square over 2. You get this result. So just we are computing. This. Okay, so I think let's go to the next step, to the empirical equation. So this is the empirical equation, phi e. You have to use 100 over pi cos inverse of lambda 1 minus 1 over lambda. So you get this result. So this is just phi e, which is uncorrected pressure. So be careful on this one. Your calculator should be adjusted into radian measure. So phi d 100 over pi cos inverse of lambda 1 over lambda. Then you get 59.278. So we are calculating at the depth d1. At the depth d, what will be phi d? And then you have again E, D, and C. So you have phi C 100 over pi cos inverse of lambda 1 plus 1 over lambda 100 over pi cos inverse of this one. You get this result. So just keep in mind these values, then we will use the curve for intermediate pi. So for intermediate sheet pi, you have just B1 and B2, then you have E, C, and D. E is this one, front, and D at a depth D, which is the pressure, and C is back base of this one. So the water is seeping through this one. So to find, using Khosla's curve now, you can just have this. Please keep in mind this parameter. I will show you the graph. So to find phi C2, read alpha first, alpha already. We have alpha, the beginning, B over D, then B1 over B, we have this one. Then to find phi C, read again alpha 8.4 and B2 over B. or 1 minus B1 over B, you have 0.81, 0.81. Then finally, you have phi E2, 100 minus phi C, you have 79.39, which is similar with the curve. And to find phi D, just for values of B1 over B less than 0.5, already B1 over B is less than 0.5. So read phi D for the base ratio of 1 minus B1 over B and subtract from 100 to find phi D2, which is at intermediate file 2, 100 minus phi C. So you get 69.278. So let me show you again the chart. Let's go to the chart for intermediate file. This is for intermediate file, Khosla's chart. This is Khosla's chart for intermediate file. So you have for alpha 8.4. This is 8.4. You can see here 8.4. This is just 8.4 here. You see, this is 8.4, 8, 9. These are alpha curves of phi C and phi E. So you have 8.4 around here. You just go like this. So once you just compute B1 over B, this is B1 over B. You have B1 over B. You compute 0.19. So please count these values, 0.2 minus 0.1 over number of divisions, it will be 0.01. Then you just have 0.2 here. So 0.19, you take this, then finally, you see, at this point, this is the intersection point from alpha 8.4 and from B1 over B. So you get phi C2. So phi C2 automatically you read out from the curve. This is phi C2, curves of phi C. Clear? Curves of phi C. Then just again, once you read this one, so B1 over B. So B1 over B, you subtract then 0.81. So this 0.81 again, if you go upward direction, so if you meet the 8.4 at this point, which is important, 8.4 at this point, you see, at 8.4, then you read out this one, which is 5. So you have here. So we are just taking the values phi C, which is this one, phi C, 20.61. 20.61 if you go like this. If you just have 1 minus B1 over B, 0.81, then you read out phi C. So if you know phi C, then finally you can have phi E2. Phi E2 means 100 minus phi C, which is 79.39. Clear? So 79.39 and phi C2 already this one. This is phi C2, which is here. This is C2. This is C2. This is E2. This is D2. Clear? So already phi C2 from the first B1 over B. Then if you meet the alpha values, then you go horizontal, this one, so you read out phi C2 automatically. But phi C is, you have to go 1 minus B1 over B, which is 0.81. So if you just intersect this one, then you go here. This is phi C. Phi C. To find phi E2, then you subtract here 100 from 100. So it will be this result. So this is phi E2. Then to find phi D for values of B1 over B, which is less than 0.5, because it is less than, because 0.19 is less than, then you have to read out this value, which is curves of phi D. Let's go to curves of phi D. Then if you go straight upward, values of alpha again you have, these are curves of phi D. These are curves of phi D. If you intersect 8.4, which is alpha value, you just read out this value. So this value will be, you have to compute already 30.722 then you have this result. So I hope this is the result. So how to read the curve? First, you read out V1 over B. You go upward until you intersect values of alpha. Then you go horizontal to compute phi E2. Then finally, phi C2. Phi C2, then you just have phi C here. Then just from B1 minus B2, if you go horizontal, you read out this one. So these are curves of phi Z. Then curves of phi E, same, you just subtract 100. Then this is curves of phi D. So this is the Khosla's chart for intermediate pile. So you can use this one or this empirical equation. You have two options, either empirical or Khosla's curve. So I hope already completed. So this is empirical equation. Be careful on this one, radial measure. So already you have E2, C2, D2. Okay, downstream pile. For downstream pile, you have floor here, floor level 200. Then you have bottom level here, then 194. If you subtract, then it will be 6 meter. 6 meter. 6 meter. Then you read out P over D, 42 over 6, 7, 1 over alpha, 1 over 7. Then you can read out this one from Khosla's chart already. I have shown you the curve. You read out 1 over alpha, which is this one, 0.1429. Then you will intersect these values. Finally, phi E and phi D will be known from Khosla's chart. So let's use empirical equation now. Empirical equation lambda, you have these results. And finally, you have phi E, which is 100 over pi cos inverse of this. You read out this value, and phi D will be this one. Then you can just have this alignment pile at upstream end, E pressure, percentage of pressure at T and at C. So sheet pile at downstream end. You have calculated these values, then finally superposed pressure. You have to write just A1, C1, D1 already computed values. So these are computed values. So these are computed values now. These are computed values already. You have A1 100% initially, it will enter, then D1 already computed, and C1 you have here, and E2, which is the percentage of pressure at this front of this sheet pile at a depth D, you have already computed, and backface, which is this one, then you have here A3, A3, D3, C3. So once you compute these values, now let's go to superposed pressure, which is the direction of flow, or the seeping of water is this direction like this. It will go like this, and finally you have to calculate. Corrections are made for correction of floor thickness, correction for mutual interference, and correction for slope of flow. So let's start thickness correction first. Upstream pile correction for thickness, you have here 78.91, which is this one, pressure, minus this one, 89.58 over 5. 5 is the depth of sheet pile. Then times floor thickness, you have floor thickness here. The thickness is already 0.75 given. So just you have here, this is plus, because just you can see as a remark, direction of flow is from C1 to C1 prime. So it will go like this. So the flow is going like this from C1 to C1 prime. So pressure at C1 is more than pressure at C1 prime. Hence correction is positive. Then intermediate pile correction for thickness, which is E2. Here you have to just compute from. So 79.39 minus 39.278 over 5 times thickness of floor, then 1.516%, which is negative. Negative because the flow direction is here. Direction of flow is from E2 prime from here to E2. So pressure at E2 is less than E2 prime because the flow direction is going like this, then hence correction is negative. Then phi C2, again, just backside, the flow is going to this direction, so from C2 to C2 prime. So since the direction of flow is from C1 to C1 prime, pressure at C1 is more than C1 to C2. Pressure at, okay, this is just 2. This is again 2. So pressure at C2 and C2 prime, you have, hence the correction is positive. Again, you have to compute other parameters and direction, just the downstream pile correction for floor thickness we are computing, which is this one at E3. So the flow direction is going like this. So from E to E3 prime to E3, so it will be negative because of what? The pressure, direction of flow is from E3. Direction of flow is from here to here. So pressure at E3 is more than E3 prime, hence correction is negative. Here, pressure at E3 is more than E3 prime according to the flow direction. So now let's go to correction for mutual interference. Correction for mutual interference. So correction for mutual interference. So the correction is positive for points in the rear or backwater, yes, and subtractive or negative for points forward in the direction of the flow. So just upstream and downstream sheet pile you have to identify. Then finally you just have correction for mutual interference. So this is the general equation for correction of mutual interference, plus or minus 90 square root of d over b1 times d plus d over b. So where just d and small d, I will tell you later on. So this is the alignment of the sheet pipe and also the Glacis Weir. So upstream intermediate pile here and downstream pile. So effect of pile 1 on pile 2. Effect of this pile 1 on pile 2. You see, the direction of flow is just the direction of flow is like this. From this to this direction. Clear? So having this, so let's see. You have to identify. So the effect of pile 2, interfering pile. Interfering pile, you give capital D and just the pile to be affected, or just the downstream, which is D, small d, which is downstream pile. So this is downstream, but here upstream. So from upstream to downstream. You see, the flow direction is from upstream to downstream, from upstream pile to intermediate pile. And just effect of this pile 1 on 2, we are going to compute. So just capital D will be just 202 minus 0.75, which is the thickness of the floor, minus 197, 4.25, and small d will be the same. You have to subtract 202 minus 0.75 minus 197. For d, elevations are given, so you have to compute. You should compute. So let's see now. C is equal to negative because the flow direction is to this direction. So effect of 1 on 2. So it will be just negative. So you have to negative, you have to put in, substitute the values. B1 is the distance between pile 1 up to pile 2. Then you have negative 2.8%. So remark, D is to be measured, D is to be measured, D is to be measured from below the level at which the interference is desired. So D will be measured below the level at which the interference is desired. So the interfering pile is 1, but pile 2 is just to be affected or influenced. So we are just having this. So effect of pile 2 on pile 1. So the correction is negative, you see, just 4 points forward in the direction of the flow. It's 4 points forward in the direction of the flow, because from 1 to 2 you are going to calculate, so it will be negative. That's why you put negative here. And effect of 2 on 1. So you go back. You go back now. So just flow is to this direction, but you are going to this effect of this on this one. We are just backward, but flow is to this direction. So this is just, you have here 4 points in the rear or backward or in the backward direction. If you are just considering, so it will be positive. So let's see. You give capital D and small d. So effect, the interfering pile will be capital D, you will take, and small d will be for the pile to be affected. So this is upstream, but here this is downstream. Upstream and downstream. So, but the flow is to this direction. So as much as possible, try to just give capital D and small d, then you calculate. D will be 202 minus 0.75 minus 197, 4.25, and 202 minus 0.75 minus this one, you just simply insert the value. So D is the depth of pile 2 below the floor of base 1. So capital D is just the depth of the second pile, which is the second pile, which is this one, the interfering pile. You can take this is interfering pile, you can write here interfering pile, the depth of interfering pile below the base of the pile to be influenced, and small d is the depth of pile 1 below the floor automatically. So you have to put positive because this is just subtractive. 4 points forward is the direction of the flow. 4 points forward is the direction of the flow, negative, but 4 points in the rear to this direction from 2 to 1. So it will take positive. So you are just of positive. So effect of pile 2 on 3. So 2 on 3, you see, to this direction. So just 4 points forward, so it will be negative. But keep in mind capital D and small d. For interfering pile, you give capital D, which is the depth of the interfering pile below the floor of this pile to be influenced, and small d is the depth of the second pile or the influenced pile below its floor. You can write. So D, let's see now. Capital D is just the depth of pile, which is the pile of 2 and below the floor of 3. So that's why 200 minus 1 minus 197, which is 2 meters. Then this is again, you can see the depth of pile 2, which is this one, the interfering pile, below the floor of base of 3. So be careful. So when you just deduct 200, this is 200 is this one. Effect of pile 2 on 3, we are just calculating. So you go from here to here, you subtract, then you have to make 187. 187, this is the bottom level of this one, the pile, which is just the depth of pile 2 below the floor of 3, below the floor of 3, which is this one. And you can see this one, small d is automatically the depth of this pile 3. The depth of pile 3 automatically from the floor, you subtract bottom level automatically. You get this value. So the depth of pile 3 below its floor. Below. So you can give now just negative because you are just taking from 2 to 3, which is 4 points forward in the direction of flow, which is from 2 to 3. So you have here upstream is the interfering pile and this is the downstream pile 3, so which is related with the flow direction, so it will be negative. So effect of pile 3 on 2 from 3 to 2, but flow is to this direction. Clear? So this is just designate capital D and small d, the interfering pile, and this is the pile to be influenced. So this is just pile 2. So flow is to this direction, but you are just having to this direction. So capital D is just the pile of this one from this floor, which is the floor of 2, which is below this one. 0.75 minus 194 you have to consider. So just this one, just effect of pile 3 on 2. You start from pile 3, then what will be the floor? So you are just have effect of pile 3 below here. You have to consider this one. Clear? So just 202 have here up to this one, up to this level. You should take from 202 minus 0.75 minus 194 because pile 3 is the interfering pile, but pile 2 is the pile to be influenced, which is upstream. So you have here. And D is the depth of pile 2 automatically. 202 minus this one minus this bottom level. So you have this one bottom level 187. But here capital D is just the depth of the interfering pile, which is from this level, from the third, which is the floor. You start from this one, from pile 2, up to this level, because the interfering pile is to this direction. So I hope these dimensions are carefully calculated. So you have the depth of pile 3 below the floor base of 2. Capital D is the depth of pile 3. Pile 3 is this one, below the floor base of 2, which is below here you have 193. So from here, from 202, you subtract 75, then you go again 194, then finally you get 7.52. And this automatically is the depth of pile 2 automatically, which is this one, the depth of pile to be influenced. So the depth of pile 2 below its floor automatically, just 202 minus this one, minus this, then get this one, then automatically you go just correction now. So you are just calculating the correction is positive because from 3 to the bottom. So you have 2.402. This is the pressure. So correction for slope of flow. A correction for a sloping impervious floor is positive for the down slope. The down slope, just the down slope. Correction is positive for down slope because it is accelerating. So the flow is going automatically without any problem. It will go to this direction. Otherwise, which is in the flow direction, and negative for the upslope in the direction of the flow. So if it is going to this direction, automatically the flow is deflecting to either side. So it will be decelerating. That's why negative. For upslope, it will be negative. So it's direction. Since downstream of pile 2 is upslope, this is the downstream of pile 2. This one, which is upslope, so you have to make as much as possible. This is the upslope direction, so it will be negative because flow is deflecting to either side, and also there is deceleration. That's why we take negative. So for slope 5, or 1 vertical to 5 horizontal, or 5 horizontal to 1 vertical, from the table of correction factor you have 2.8%. Then you have elevation now 204 at this point, and 202 the floor of this one. So you have horizontal distance 10 meter. What will be this vertical distance using slope of this one, 125. So automatically slope V over H, 204 minus 222, then over H, 1 over 5, then Vs, which is the horizontal distance of the sloping upstream side, be 10 meters. This is the horizontal distance. Then correction will be plus or minus BS, which is the horizontal distance of the sloping floor, divided by B1, which is just the total dimension up to the downstream side. Then you have this negative D2 upslope. So calculation of corrected pressures now. Corrected pressure will be calculated pressure, which is uncorrected from chart or from empirical. We have calculated, and correction for thickness of floor, and correction for mutual interference, and correction for slope of floor. So this is just a correction. Total correction will be computed. Total correction will be computed. So you have E1, C1, D1, etc. So you have these are uncorrected pressures. Now let's correct. Pile number 1, which is upstream slope, phi C, which is already computed first. So you have 1.39, which is correction for thickness of floor, then mutual interference, then you get this result. Then next, pile number 2, which is intermediate pile. You have 79.39, so you get negative for mutual interference correction. Then you have 2.8, then minus again for this one, slope of floor. Then you get this. So these are the corrected pressures. Phi C again, you calculated this. Then you have mutual thickness floor and mutual interference. Then these are the corrected pressures. Once you calculate the corrected pressure for pile number 3, again you have here just you have phi E 33.17, which is uncorrected pressure. Then correction for thickness of floor for downstream here. Then you have mutual interference. These are corrected pressures. So once you compute corrected pressures, let's go to pressure. So uplift pressure here. So total head will be 205 minus 200. Upstream water level minus downstream, we get 5 meters. Then uplift pressure at key points. This is the requirement. So pile number 1 upstream, PC, which is percentage we have multiplied by the total head, we get this result. And for intermediate pile, PE, which is at this point, the corrected pressure will be 74.25% already computed. So you have over 100, then we get this result. And PC at this point, corrected pressure at C will be this one. And for downstream, PE will be this one. And for C3, it will be 0. So uplift pressure at the beginning of downstream slope of floor, you have already computed 3.712, which is this one at intermediate pile here. Then you have here slope like this. Then it will go like this here. So just this is for simplicity we are putting. So you have here, then you have to subtract this potential, which is pressure 3.685, which is this one, PC minus this one, PC minus PE over 8 meter distance you have here, 8 meter, then times 10, you get this is just the uplift pressure at the beginning of the downstream sloping floor. This is the result. Then uplift pressure at the beginning of downstream horizontal floor. At the beginning of downstream horizontal floor will be, you have to subtract this one, 3.685, but the distance will be 24. First 10 meters, but the next one 24. You just have these results because distance already given. But here 10 meter already you have 10 meter from just slope up to the distance. So this is the 10 meter distance. Then you have here from here up to here 10 plus 12, 22, 24. So we are just putting here up to this one at the beginning of at the beginning of this flow. So the corrected percentage pressures at varied key points are tabulated as below. Already upstream pile 1, you can just have this given 100%, by D1, by EC1. Then for intermediate pile number 2, already corrected pressures are this one, is 9.278% and 64. And for downstream pile number 3, you have this by E3, by D3, and this one. Then these are just E1, C1, D1. These are corrected pressures. So once you have corrected pressures, you go for next step, which is hydraulic grade line. So how do you compute hydraulic grade line? Hydraulic grade line is very important. Just you can check thickness of floor and also ordinate of hydraulic grade line for thickness for checking purpose. So check for thickness now. Check for thickness. Thickness required, you have 2.6 to 3.678, which is 2.966 meter thickness at A. Thickness at A, so more than 1.5. This is a downstream floor. Thickness unsafe for uplift, unsafe, which is this one, 1.5, which is unsafe because this is more. And thickness at B, at the downstream end, already you have 3.631, then 2.928. This is for checking purpose. If thickness is given, you have to check using this one. So unsafe for uplift again because it is more than 1 meter. So uplift pressure at intermediate pile PE2 or D, you have here PE2 at this point. At this point, then thickness required will be H over G minus 1 or D 2.99, which is more than 2.99, which is more than 1.5. So it will be just unsafe for uplift, unsafe for uplift pressure. So I think, and it is also more than 1 meter or 0.75. Then uplift pressure at downstream pile or D, you have a downstream pile. This one, E3. E3 also 1.53. Then finally, thickness required will be this one, 1.323, more than 1 meter. This is also unsafe against uplift. Check for exit gradient now. Check for exit gradient. Check for exit gradient. So given safe exit gradient you have here, then maximum seepage height will be 5 meter. Then depth of downstream pile 6 meter you have. Then alpha will be B over D, which is 7, and lambda will be 4.035. Then exit gradient will be H over D times 1 over pi square root of lambda, 5 over 6, 1 times 1 over pi times this one. So this is 0.132 less than the given safe exit gradient. So it is safe. This is result is less than, so it is safe against exit gradient, and it is just fine sand. For fine sand, it is safe because it ranges from here up to here. So by referring plate 17.3 for any value of alpha, which is B over D, already B over D, keep in mind, we get what? 7. The corresponding value of 1 over pi square root of lambda can be read off. When H and D are given, then exit gradient automatically calculated using exit gradient chart. So let me show you exit gradient chart now. Exit gradient chart. This is the exit gradient chart. If you calculate 7, you read out this value. Here, you read out this value. This value. So if you read out 1 over pi square root of lambda, then you put here, then you multiply by H over D, then you can calculate exit gradient. So you read out here, you intersect at this point, then you have here. Then you multiply by H over D. So this is just exit gradient. Exit gradient. You can see this is exit gradient chart. You can read out. So steps for calculating exit gradient or hydraulic grade line. Steps for calculating hydraulic grade line. This is general. The first step is determine the seepage path. The seepage path identifies the likely path of seepage flow beneath the weir. Calculate the creep lengths for Blaise theory, especially measure the length of seepage path. the total travel length of the seeping water under the floor of the weir, and determine the hydraulic head loss, calculate the difference in hydraulic head between upstream and downstream water level, and calculate the hydraulic gradient, which is important. Just divide the hydraulic head loss by the creep length for Bliss theory. If you have hydraulic head loss, if you divide by total creep length or total seeping of water under the floor of the weir, you will just have hydraulic gradient. Then draw the hydraulic gradient, plot the hydraulic gradient, hydraulic grid line based on the calculated hydraulic gradient and the seepage path. Then safety check. You have to check safety check against uplift and also against piping or undermining. Ensure that the calculated hydraulic grid line is safe and that the hydraulic gradient is below the critical gradient, the critical gradient to prevent piping or undermining. So once you just check against piping and thickness of floor against uplift, then it will be safe. So this is just the plot of hydraulic grid line, which is HGL. So you have flow condition, just pond level at upstream with no flow at downstream. Then upstream water level, you put 205. Downstream water level, again 200. The head is the difference of this one. The percentage of pressure upstream pipe already you compute here. These are upstream pipe we compute here. For downstream pipe, for interblade pipe, you compute this one. And for downstream, these are the computed corrected pressures. Corrected pressures. Clear? These are the corrected pressures. The corrected pressures. Now, let us see. Just have, if you multiply by percentage of pressure, you multiply by this one, this by this one, this by this one, it goes on like that. And hydraulic grid line, again, you have hydraulic grid line level, 205 first, then there is a drop in water level, you will see this, then head loss will be computed. So this is just overall concrete Glacis Weir. So you have P1, C1, etc. Then the hydraulic grid line will be like this. It will go like this. Calculation step. So you have just the percentage of pressure. You multiply this one total head by 100%. You multiply. Then again 5 times this one. You multiply. Again just you multiply this. Multiply this one by this percentage. By this percentage, by this percentage, then you just have these results. After multiplication, you have computed ordinate of hydraulic grid line. Ordinates of hydraulic grid line. Clear? Ordinates of hydraulic grid line. So once you have ordinate of hydraulic grid line, then you will have hydraulic grid line level. Level also. Just this is just 100%, so you just have this one, you have to subtract. Then elevation, you have here, you have just 5 minus this one, just this elevation. Elevation, you can compute. Again, just subtract this one from the first step you have here. Clear? So elevation, just the drop from here, from 205 elevation of this one, you subtract this minus this total head you have, then you subtract this one, then elevation. So hydraulic grid line elevation will be computed like this. Then head loss will be, you have head loss at the beginning when there is no any head loss, then you just have just here from this 205 you subtract the level of this one at this point d1. Just the hydraulic grid line below this level will be computed. Clear? So the hydraulic grid line will be from upstream sheet pipe. It will start like this, then it will go like this up to this level. So thickness is designed based on this hydraulic head. This hydraulic head, at every point you can calculate the thickness of the floor. The thickness of the floor. So already completed. So the profile can be drawn here. Just floor distance. You just have this one. Then finally you can arrive at the solution. Clear? So this is just how to calculate the hydraulic grade line. Okay, thanks for watching. If you have any question or doubt regarding this topic, please forward through comment suggestion box and I will reply on it. Okay, please like, share, comment and subscribe to our channel and click the bell icon. Okay, so ጥያቄ ካላችሁ you can forward and then እንደገና በደንብ ጥያቄዎች መስራት እንችላለን። ኮመንት ሰጀሽን ቦክስ ላይ አስቀምጡ። ታንክ ዩ ቬሪ ማች